Hi there, and welcome to Lesson 6.3a, Solving Proportions. Today we're going to look at what a proportion is, and we're going to investigate a few different ways in which we can solve for a missing value in a proportion. All right, let's first take a look at these two sets of pictures. Which pair of pictures would you say are proportional? I bet you think you know. Let's take a look at the dimensions. The dimensions are going to prove as to why you're right. I bet you pick set 2. Absolutely. So why are these images proportional? Well, a proportion is two equal ratios or rates. So in this case, I've got 4 inches and 5 inches, inches to inches. That's a ratio. So I could write for the smaller image a ratio of the width to the length of the picture, 4 inches to 5 inches. And then if I look at the larger image, the ratio for width to length would be 8 to 10 in that picture. So why are these two ratios equal? Why are these two fractions equal? Well, let's take a look at why that is. There are 3 different ways that we can prove that a set of fractions or two ratios are equal to each other. We can look at 3 different relationships in the numbers. The first thing we can do is to take a look at the relationship just horizontally. So if I look horizontally across, I can see that when I double the width, I also have to double the length to get a proportional picture. Well, same thing with fractions. If I double the numerator, I have to double the denominator, and I produce an equivalent fraction. So this is the horizontal relationship between two fractions that makes them equivalent. Now let's take a look at the vertical relationship. I can look vertically and I can divide both of these fractions. And if I divide them and the numbers are the same, then they're equal to each other. So if I take 4 divided by 5, I would get 0.8. And if I take 8 divided by 10 in my calculator, I get 0.8. They're equal. So this is the vertical relationship that's going to prove that two fractions are equal. And you guys have used that before to compare fractions. Now, the final and third relationship that you can look at between any two sets of equal fractions is the diagonal relationship. And this is something that's new that you probably haven't seen before. I can multiply diagonally, and my products should be the same. So 8 times 5, there I get 40. And if I multiply diagonally here, 4 times 10 is also 40. The cross products of any two fractions, if they're equal, then the fractions are equal. And that's always the case. And you might be thinking, no way, that's not even true. There's no way. It actually does work. So let's just take a quick peek, and we're going to look at some equivalent fractions. And I'm going to prove to you that their cross products are always going to be equal. And this is super helpful when you're solving proportions. So let's just take this 1/2. Let's multiply the numerator by 4 and the denominator by 4. 1/2 is equal to 4/8. Yeah, we know that that's true. So let's take a look at the cross products. 4 times 2 is 8, and 1 times 8 is also 8. The cross products are equal. You're probably thinking, yeah, still, yeah, right, Johnson. You're nuts. Let's try it again. So 2/3, let's multiply the numerator and denominator by 2. We're just going to double the numerator. We're going to double the denominator, 4/9. So these two we know are equal fractions. And so what we want to do here is, I can't even do that. 2 times 2 is 4, 3 times 2 is 6. What was I thinking? Okay, 4, you're probably thinking that's not equal fractions. Now they are. 2/3 and 4/6 are equal. So let's multiply across. Let's multiply the cross products here. So 4 times 3 is 12, and multiply across this way. 2 times 6 is also 12. They're equal. It works again. All right, with 3/4, let's take and multiply by 3. So let's do times 3 in the numerator. I did that right. And times 3 in the denominator, and I did that right. 3/4 and 9/12. So you guys know that those are equal fractions. Let's multiply across. 3 times 12 is 36, and 9 times 4 is 36. It works every single time. Isn't that cool? Well, this relationship, this diagonal relationship, which we call cross products, product because we're multiplying and we're going across, this relationship is super helpful when we're solving proportions, and you're going to get to see today why it is helpful. All right. So a proportion can be solved to find a missing value. And that's kind of going to be our goal today. If I had a missing value, like I didn't know that that was 8, how could I figure out that it's 8? And the way we're going to do that is by either looking at a horizontal relationship, a vertical relationship, or a diagonal relationship within those two fractions. That is our plan. Okay, so let's investigate different ways of solving a proportion. And you're going to learn a new way of doing that today as well. All right. Okay, our first example. In your notes, you're going to see it says method 1. Here we have 2 baseballs costing $5, and we're asked how much will 7 baseballs cost. So we know the rate with one of our situations. 2 baseballs cost $5. Just to keep this in mind, we always want our money on top, so that our money's on top and our baseballs are going to be on the bottom when we are setting up this proportion. So 2 baseballs cost $5. Let's write that down as our first rate. $5, 2 baseballs. Okay, I have my label over here on the side to remind myself. Now, how much will 7 baseballs cost? Okay, well, I want to buy 7 baseballs. So I know baseballs goes on the bottom and X is going to go up here on the top. I don't know how much they're going to cost. Well, we can use the idea of unit rate, which is a vertical relationship. So when I find the unit rate, I'm going to figure out how much do I pay for 1 baseball. And to do that, I would divide 5 divided by 2. And when I take 5 divided by 2 in my calculator, I get 2.5, which is $2.50. Okay, so $2.50 is what I'm paying for each baseball. $2.50 per baseball. But that doesn't answer the question. The question says, how much will 7 baseballs cost? So knowing that they're $2.50 each, I can take my 7 baseballs and I can multiply by $2.50 each. Okay, so 7 times $2.50, I would pay, it's hard to see my calculator here, I would pay $17.50 for those 7 baseballs. $17.50. All right, so I'm taking my unit rate and I multiplied by 7 because there was 7 baseballs. All right, so that's my first method is unit rate, which is a vertical relationship. I'm just dividing vertically. Okay. Now the second method that you can use is called factor of change, and this is a horizontal relationship. So let's look at the situation. We got the same situation we did before. We're going to put money on the top. We're going to put baseballs on the bottom. All right, so 2 baseballs cost $5. $5, 2 baseballs. Remember, money on the top. Well, how much will 7 baseballs cost? So we don't know how much money. Put that on the top, but we do know we're going to be paying for 7 baseballs. All right, so same exact proportion as we had before. Well, last time we looked vertically and we found unit rate. Now let's look horizontally. This is called factor of change. So if I look horizontally, from 2 baseballs to 7 baseballs, what do I multiply by? How many times as many baseballs am I buying when I buy 7? So to figure out what we're multiplying by, I can divide 7 divided by 2. That's 3.5. I am buying 3.5 times more baseballs. So if I'm buying 3.5 times more baseballs, wouldn't it make sense that I'm going to pay 3.5 times as much money for those baseballs? Yeah, exactly. So let's take the 5 and let's the $5 here. We're going to multiply it by 3.5. And again, we're going to get $17.50. Okay, so we just multiplied the 3.5 by 5 because we're buying 3.5 times as many baseballs, so we're going to have to pay 3.5 times as much money, and that's factor of change. We're looking at the horizontal relationship. Okay, last method, and this is the most exciting because this is cross products, where we're just investigating that the cross products of any 2 fractions or any equal fractions are also going to be equal. So let's set this up again a third time. We have dollars over baseballs. Okay, so by this time we know $5 2 baseballs, X dollars for 7 baseballs. Okay. So now we know that that these are 2 equal fractions, the cross products will be equal. So I'm going to simply multiply going across. I have 5 times 7, and that's 35. Now I know that going across this way also has to be 35. But what do I see? X times 2. So I'm going to write it as x times 2, or 2x. I'm going to bring down the equal sign. Now I have a one-step equation to solve. If you want to, you can write it right here on this line. Let's solve the one-step equation. We're going to divide by 2, and we get x equals 35 divided by 2. I bet you know what that is. 17 and a half. Yeah, it is 17.5. But remember, this is how much money. So this is, this is money. So we want to go 17.50, even though our calculator says 17.5. Money goes out to the hundreds place. So again, I get $17.50 for the 7 baseballs. And here I use cross products, knowing that they both have to be 35. 2 times what number gives you 35? And you can find that out by solving a one-step equation. Pretty sweet. So this is the diagonal relationship between equal fractions. All right. So let's see now if we can figure out the best method for solving each of the following proportional relationships. We're going to look vertically, horizontally, and diagonally and see which one's going to be our easiest way. Okay, so let's look at example number 1. Back to the notes. I can buy 6 pairs of socks for $20. How much will 18 pairs of socks cost? All right, so we got socks and we've got dollars. We know money goes on top. Money over socks. I'm going to put the label over to the side. That way in my proportion, I don't have a bunch of labels. I just have numbers. Okay, so we got 6 pairs of socks, $20. So that is our first rate, $20 for 6 pairs of socks. Now we're being asked how much money will 18 socks cost? Okay, so where's socks going to go? 18 socks will go down here. And we want to know how much money are we paying for the 18 socks? All right. So let's look at this pair of equal fractions, our equal rates. Let's look vertically. Do you see a relationship between 20 and 6? Me neither. Let's look horizontally. Do you see a relationship between the numbers 6 and 18? Yes. If you see a relationship vertically or horizontally, do that. Do that first before you look diagonally. So I can see to get from 6 to 18, I multiply by 3. So what this is saying is I'm really buying 3 times as many socks. So it's going to cost me 3 times as much money for those socks. So let's figure out how much money this is. $20, and we're going to triple it, and that's going to give us $60. If we triple the number of socks we're buying, we're going to triple the cost of the socks that we're buying. All right, so here we were using a horizontal relationship with those 2 equal fractions. Let's take a look at number 2. I can buy 6 chapsticks for $18. So how much will 11 chapsticks cost at that rate? All right, so we've got dollars on the top, chapsticks on the bottom. I'm just going to abbreviate that. Okay, so let's look at our first rate. 6 chapsticks for $18. All right, $18 on the top, 6 chapsticks on the bottom. How much will 11 chapsticks cost? So I'm going to put 11 on the bottom. How much will 11 cost? So $18 for 6. How much money for 11? Okay, now let's look horizontally. Ooh, icky relationship between 6 and 11. I don't know what to multiply by 6 to get 11. Let's go vertically. 18 and 6. Ooh, there's a vertical relationship there, right? Yes, between 18 and 6. Now, look over here. I want to get from the 11 up to the x. So I want to go from bottom up to top. So let's look from bottom up to top over here. How do I get from 6 to 18? Times 3. Well, this is our vertical or unit rate relationship. If I take 18 divided by 6, it's $3 per chapstick, right? So then if I do the same thing over here to get from 6 to 18, I take 11 and I multiply it by 3. Well, think about this. If you're buying 6 chapsticks and they're each $3, that's $18. If you're buying 11 chapsticks, they're also $3 each. And that would be 11 times 3, 33. $33 for those chapsticks. So this is a vertical relationship. I'm looking at the numbers and I see, ooh, multiply by 3. I do the same thing to the other side. They're equal fractions. Okay, so vertical relationship, which is that unit rate. I bet you've been excited to try this last one to see if you get to use the cross product method. Let's see if we can. Okay, I have 7 pens for $12. How much will 11 pens cost? Money, pens, money on top. Okay, so let's look at our first unit rate. 7 pens, $12. So $12, 7 pens. Okay, now we're going to figure out if 7 pens cost $12, well, how much will 11 pens cost? How much money will 11 pens cost? Where's the pens going to go? Down here with the other pens. Okay, now in this case, Do you see how there's not really a nice relationship going horizontally? 7 times what is 11? I don't really know. Either with the 12 and the 7 vertically here. 12 divided by 7 or 7 divided by 12, it's going to be an icky number. So then I can use the cross product method. I know that the cross products should be equal if the fractions are equal, and they are, because they're equal rates. So let's take the numbers first. 12 times 11. So in my calculator, 12 times 11, I get 132. So this is 132, which means this other side has to also be 132. Okay, so this needs to be 132 also. They need to be equal. So in order to do this, I'm just going to get a little piece of paper here. They're both going to be 132, right? So I'm going to multiply going across here. X times 7 is 7x, right? I've multiplied across here, get 7x. I multiply across here, get 132. What I have right now when I bring down the equal sign is a one-step equation. So I'm going to solve the one-step equation. I divide by 7 here, I divide by 7 here, and I get x equals 132 divided by 7. 132 divided by 7. And that's going to give me about, look at this, 18.2 places after the decimal point. Do you see how that's an 8? And then the 5, if you look at the 5, the next digit's a 7. So I was going to bump that 5 up to 6. So the 85 cents is going to bump up to 86 cents. So we're going to say it's going to be about $18.86 for 11 pens. Now, I want to show you something. Remember how we said that both sides were equal and both sides are 132. You know that this 12 times 11 is 132, so it means x times 7 is 132. So if I want to figure out what number times 7 is 132, I could use my calculator and just type in 132 divided by the 7 gives me what? And that's the x value, and I get the exact same answer. Okay, so seeing how I can set them up to equal 132 equals 132, right? Or I can look at x times 7 as 7x, and I do it with a one-step equation. I like this method because you're showing your work. Okay, so we've learned 3 different ways that we can solve a proportion when we look at a vertical relationship within the rates, or a horizontal relationship, or a diagonal relationship with our new method called cross products. Thank you very much for joining me. Have a great day.